Hello grade 7. In today's video we're going to be starting a new mini unit on number patterns and sequences. And to start off we're going to take a look at a basic pattern of dots. So I'm going to draw a small pattern of dots here. And then we're going to use this pattern to understand a little bit more about patterning. So first of all, let's take a look here. We want to talk about, at first, the order of the patterns that are here. So we kind of give it a number, and we count through, and we say that this is the number of terms of the pattern that we're dealing with. So this one here, this is the first term. And so we say that the n, or the number of the term here, is 1. Another way we could say that as well, we could say that we are at term 1. And to show that, I just write a T to represent term. And I put a little 1 there to show that this is term 1. We could say that this one here, this is the second term. So the number of the term here is 2. That's not the number of the dots, just the number of the term, the order in the pattern that we are in. And so this would be term number 2. This would be what number in the terms that this was 1, this was 2, this is just the next one, 3. This is term 3. This number is 4, and so we say that this is term 4. Now we can also start to take a look at a pattern here, or a sequence of numbers, in order to try to understand what's going on. We can see what's going on from the pictures here, but we're going to create a little bit of a rule that might eventually help us figure out what term 50 might be. How many would be at term 50? How many of these dots? So first of all, at term 1, we have how many dots? Well, at term 1, that equals 1 dot. At term 2, that equals 1, 2, 3 dots. At term 3, that equals 1, 2, 3, 4, 5, 6 dots. At term 4, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots here. So at the fourth term, the number of terms, this is our fourth term, or our fourth number in the sequence. A sequence is just a listed order of numbers. We have the number 10. We could write down this number sequence then as 1, 3, 6, and 10. And maybe some of you are already starting to see a pattern. We're going to get into patterns a little bit later on and understanding some of these patterns. But for now, this is our number sequence for this term. And this could continue on and on and on and on. Just because it stops at 10 here, we could do what's n5, or what's the fifth term, and figure out where to go from that spot too. So we'd say the first term, t1, equals 1. The second term, t2, equals 3. The third term, t3, equals 6. And the fourth term, t4, equals 10. Maybe you're seeing a bit of a pattern. If I was to go on to the fifth term, here I started with 1, added 2 underneath, 3 underneath that, 4 underneath that. What do you think I would add underneath next to get to term 5? In other words, my T5 would be how much? Well, here I added 2, added 3, added 4. My next would be adding 5 to this term. So I'd be at 15. Okay, well, what would T6 be? Well, this one added 2. This was plus 2, plus 3, plus 4, plus 5. So this one must be plus 6. T6 would get me to 21. So I'm able to kind of figure that out through using these terms and figuring out what the next term would be in the following sequence. This is the end of this beginning explanation here. The next little bit of this video, I'm going to be diving deeper into the examples that are provided. If you'd like to stick around and listen to some of those explanations, feel free. If you'd like to take a look at the explanations in the PDF, you can do that as well. Let's take a look at example 1. Example 1 tells us find the next two terms of the sequence, and it gives us the sequence 12, 5, -2, -9, and then it says ... So we need to find the next two terms. We have term 1, term 2, term 3, term 4. We need to figure out what term 5 and term 6 are going to be. So that's what we don't know. Well, we need to take a look at the numbers that are here, and we need to take a look to see if there is a pattern. One of the first things that we can do when we're taking a look at the pattern is we can ask ourselves, are these numbers or are these values going up or going down? And that might give us an idea of whether we are maybe adding to our pattern or subtracting to our pattern. We see going from 12 to 5, we are going down. The next thing that we would check is, are they going down at the same rate or at the same amount? And that could tell us whether we are adding or subtracting, or whether we're multiplying or dividing, or whether we're doing kind of a hybrid of that, and whether we're doing something a little bit stranger. So to get from 12 to 5, what I had to do was subtract 7. That got me from 12 to 5. Does that work here if I go from 5 to -2? Yeah, subtract 7. -2 to -9, I subtract 7. So we seem to have found a bit of a rule for this pattern. And that's a big part of this unit, is trying to figure out some of the rules to the patterns. Okay, so if we're minusing or subtracting 7 each time, then the next term here that we're trying to find must be, follow the same rule, subtract 7. So I'm starting at -9, subtract 7 from that. My term 5 then must be -16. And then I need my final term, T6. I'm going to do the same thing, subtract 7. That's my pattern here, which is going to give me a -23. So here we were able to complete the pattern once we found the rule, and we were able to find out that the term is obtained by, the textbook says adding -7. You can either use that term, or you could just say subtracting 7 from it as well. But that is the rule of the pattern, and so using that rule we were able to figure out term 5 and term 6. Alright, our next example gets a little bit trickier here. It again asks us to find the next terms, the next two terms of the following. And so let's take a look at it. We start off with 3, 6, 12, and 24, and then it says ... It still says find the next two terms. That's what we're going to be doing for most of the stuff today. So let's take a look. Well, we see we are going up, so let's see if we can do some adding here. Going from 3 to 6 would be a +3. 6 to 12, though, is a +6. So it's not following a pattern that way. It's increasing, though. So maybe there's something that we can do with multiplying. Well, to get from 3 to 6, we have to multiply that by 2. To get from 6 to 12, oh, we multiply that by 2. 12 to 24, multiply that by 2. It seems like we've now found our rule or our pattern, and so now we're able to figure out our term 5 and our term 6, our 5th and 6th term. All we need to do is multiply by 2. That would give us a term 5 of 24 times 2, which is 48. Term 6 would be 48 times 2, which would be 96. So finding that rule, I'm now able to figure out my answer from there. Let's try another one. Let's try the next part of example 2. We have 54, -18, +6, -2, ... Okay, this one gets a little bit trickier here. You see that we're flopping back and forth between positives and negatives. Just to give you a little bit of a heads up or a little bit of a hint, whenever you see that, that tells you that you are either going to be multiplying or dividing by a negative number. Because remember that a positive times a negative or divided by a negative is going to give you a negative. A negative times or divided by a negative is going to give you a positive. And then that positive times or divided by a negative is going to give you back to a negative. So that means that term 5 is going to be a positive, and then term 6 should be a negative again. Let's take a look. Here I am going down 54 to negative 18 to 6 to negative 2, but as you can probably see, it's not in a specific pattern. When I have something like this, where it is going down this time, I know that I'm not going to be multiplying. Instead, I'm going to be dividing. And so I already know that it's going to be a negative. So what negative number do I need to divide by 54 to get to negative 18? And maybe you could try a number of things on your calculator, but eventually you get to the point where it is divided by negative 3. Now, the textbook actually uses something a little bit different. The textbook actually does talk about this being a multiplication question. Dividing by negative 3 is actually the same as multiplying by negative 1 over 3. So we talked about reciprocals, and so we can change from a dividing to a multiplying by just getting the reciprocal of it, which is the flipped version of it. So negative 3 over 1, the flipped version or the reciprocal version of that is negative 1 over 3. To go over here, let's just double check that again. Divide negative 18 by negative 3, and I'm going to get positive 6. Divide positive 6 by negative 3, I'm going to get negative 2. So now term 5 is going to be negative 2, and I could think about it either way, times negative 1 and negative 1 over 3, or divided by negative 3. Either way, that's going to give me a term 5 of 2 over 3, or 2/3, and that's a positive because I'm dividing a negative by a negative or multiplying a negative by a negative. Term 6, this is going to be a little bit trickier. Here's where sometimes the multiplication actually makes a little bit more sense. If I have 2/3 times negative 1 over 3, I can just go straight across the top and straight across the bottom to get negative 2 over 9. And that can help me kind of visualize it a little bit better. I am going to be a negative this time around, negative 2 over 9. And so I was able to find the pattern, and then I was able to use the pattern in order to figure out what my 5th and my 6th term is going to be. Excellent. Let's take a look at example 3 now. Example 3 is, it does add in another element to it. Example 3 gives us quite a bit of a diagram. And it gives us a diagram using kind of matchsticks. And it kind of gives us this box pattern here. And it says, okay, this is going to be term 1. Term 2 is going to be the same sort of thing, except for we're going to add another box onto the side. Term 3 is going to be 3 boxes. And term 4 it gives us is going to be 1, 2, 3, 4. 1, 2, 3, 4. And so those are our terms here. The other part of this question that it tells us is that each matchstick is 3 centimeters long. So this length here is going to be 3 centimeters. This length is going to be 3 centimeters. This 3, all of those things. That's going to come into play in a little bit. It says, let the number of matchsticks in the nth pattern be Tn. So what that means is the nth pattern. If I'm talking about the nth pattern, that just is saying what number pattern am I on, right? This is the first pattern. So my n is 1. This is my second pattern. This is my third pattern. This is my fourth pattern because my n, the number of pattern that I'm on, is number 4. So T4 just represents the number of matchsticks at the fourth pattern. T10 represents the number of matchsticks at the 10th pattern. We could say that Tn then equals the number of matchsticks at the nth pattern. So that's kind of a little bit of our rule there, where we could plug in any number for n and work at that. It also says that the perimeter of the nth pattern will be Pn centimeters. So Pn is going to equal the perimeter. Perimeter is just the area around the shape, the outside area. And remember that each matchstick is 3 centimeters long. The perimeter of the nth pattern. So for example, at the fourth pattern, P4, we would figure out what the perimeter is at P4 in centimeters. In centimeters. Okay, so we have our work cut out for us, and they actually give us a little bit of a chart to work with as well. And the chart is going to give us at the very top, it's going to give us the terms. So in other words, it's saying, okay, at the first term, at the second term, at the third term, at the fourth term. I'm going to have to figure out my numbers based on that. And the box doesn't look very straight, but that's okay. And then our next ones is going to be our, so this is kind of our n. This one here is our Tn. In other words, what is the amount of matchsticks at that term number. And then the other one is going to be Pn, which is what is the perimeter at that term number. So let's take a look. At the first term, how many matchsticks do we have? Well, we can count them. We have 1, 2, 3, 4 matchsticks. So the Tn at the first term is 4. Okay, well now let's see if we can figure out the perimeter. So the perimeter is the area around, so 3 centimeters here, add another 3 centimeters here, another 3 centimeters here, and another 3 centimeters here. So I'm adding 3 plus 3 plus 3 plus 3 to give us a total perimeter of 12 centimeters. Perfect. Let's take a look at term 2. Term 2, we need the number of matchsticks. We can count them. 1, 2, 3, 4, 5, 6 around the outside and 1 in the middle, so 7. So term 2 is 7. The perimeter, okay, well we have 3 plus 3 plus 3 plus 3 plus 3 plus 3. Notice that I do not count the 1 in the middle because that is not the total outside area. So I really have 1, 2, 3, 4, 5, 6 sides that are 3 centimeters long, which would give me 18 centimeters. T3. Let's figure out our third term here. How many do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the perimeter? Well, 1, 2, 3, 4, 5, 6, 7, 8 around the outside, 3 centimeters each, so 24 centimeters. And maybe you're starting to already see a pattern. Yes, we can still count out T4, and we will still count out T4. But maybe you can actually start to predict it. So Tn went from 4 to 7 to 10. Maybe you have a guess as to what this would be before you even count. Pn went from 12 to 18 to 24. Again, maybe you have a guess here as to what that might possibly be. We'll get to that guess in a quick minute. So here, let's count the number of matchsticks in the fourth term in this pattern. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with 1, 2, 3 in the middle. So that gives us a total of 13 matchsticks. The perimeter, we have 10 matchsticks around the perimeter, and they are 3 centimeters each, so it's a total of 30 centimeters. So now we are able to complete our chart based on that bit of information. That's the first part of the example. The second part of the example asks, find T5 and P5. Okay. So I have to find the fifth term, and I have to find the perimeter of the fifth term as well, which is just really the next one. And hopefully you're starting to see a pattern. If you haven't yet, let's take a look at it. The term here, we went from 4 matchsticks to 7 to 10 to 13. It is increasing, and it's increasing by the same amount. It's increasing by 3 each time. So plus 3, plus 3, plus 3. Our fifth term is going to be 13 plus 3, which is going to be 16 matchsticks. Our perimeter is increasing at the same rate. It's increasing by 6 each time. Plus 6, plus 6, plus 6, plus 6. So our new perimeter is going to be 36 centimeters all the way around. Hopefully this helps, and as you step through your Try It questions, please remember that Try It 1 is going to match with Example 1, Try It 2 with Example 2, and Try It 3 with Example 3. I hope you have a great day and a great job working on your math.